Good day, class. I'm Mr. Stanley, your basic science teacher. And last time we talked about our solar system, the solar system, right? Yes. And we also talked about under the solar system, the components, which is planet, right? Yes, we have 9 planets, but inside the ninth planet, one has been taken off by scientists. And the one that has been taken off is Pluto, if you could remember, right? I said Pluto has been removed from the components of a solar system. Currently, we have 8. But today, we're going to talk about the components of the solar system, the location, which is the distance from the sun, how far each of them each, and how are they measured? How was they measured? Were measured through what we call astronomical unit. Astronomical unit, AU, is how they use in measuring them, and is equal to 150 million kiloliters. Okay, that's it. But what we majorly focus on is the time each of these planets, take to complete one revolution. When we say revolution, one complete turn. Like if you start from here, for example, to get back to that point, as a complete turn or revolution. So how many times does it take each of them, our 9 planets? So it's what we're going to focus on. Like I said, the way they measure this is through astronomical unit. Number one, our first one is what last week, if you remember, we talked about what? Mercury, right? Do we know Mercury? Do we still remember? Mercury is our first planet. Our first planet is Mercury, and it's measured, the distance it covers is 0.4 AU, which is astronomical unit. That is it. That's if you can see the value is small, right? Yes, that is how close it is to the sun. Then how many days does it take to complete one revolution? How many days? It takes 88 days. I'll say it. It's 8 days before it will like. Let me just use here. Before this is the starting point, for example. Before it rotates from here, get back to that same point. It takes how many days? 88 days before it will take from here, rotate back to this point to complete one revolution. Remember, the sun is the center of our solar system. So Mercury is very close to the sun, and it takes 88 days to complete one revolution. What did I say? It takes 88 days for Mercury to complete one revolution. That is the time. Then the second one is what? After Mercury, we have what we call Venus, if you remember from our last week lesson, right? Venus. And Venus, its distance from the sun is 0.7 rather. This is 7, okay? Its distance from the sun is 0.7 AU. Don't forget, AU means astronomical unit. Okay? Its distance from the sun is 0.7 AU. And how many days, which is the time it completes one revolution, how many days or how many times? It takes 225 days. Could you just imagine? 225 days. That's a long period of time before it completes one revolution. 200 before it start, like I earlier said, from this spot, before it rotates back to that same spot, it takes it what? 225 days. Okay, do you understand? Okay, the third one is what? Our Earth. Earth, right? The Earth, the distance from the Earth, the distance from the Sun is just one AU. Is distance. is 1 AU. Then how many days does it take to complete one revolution? It's three. I think you must have heard 365 1/4 days before it completes one revolution. What did I say? 365 1/4 days. The Earth takes 365 1/4 days to complete one revolution. Do you understand? Okay, good. Then moving on. Our fourth one is what? Mars. 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 And its distance from the sun is 1.5. Remember, Earth was 1 on the dot. The Mars 1.5 AU. And how many the times for one complete revolution? It takes 87 days, almost like the Mercury. 87. The Mercury is 88, but the Mars takes 87 days to complete one revolution. Okay, do you understand? Right. The next one, the fifth one is Jupiter. Jupiter. Okay? Jupiter. This is our fifth planet. And its distance from the sun, is 5.2 AU. What did I say? 5.2 AU. That is its distance from the sun. And the time for one complete revolution, it takes 11.9 years. 11.9 years before it completes one revolution. 11.9 years. Remember, the other ones were what? Days. Or this one is years. Jupiter, 11 years. So it's far. That's why if you could go back, or if you remember our first lesson last week, I talked about the one that are closer to the sun, the giant planet, right? And the terrestrial planet. The giant planets, the reason why they are giant, because they are they are far from our solar system, which is the sun. They are far, that's why they are giant. Do you understand? So from here it proves that, right? And one of them is Jupiter, if you could remember, right? Jupiter, and its value is different from this one. It takes 11.9 years to complete one revolution. Okay, let's move on. After Jupiter, what do we have? Our next one is what? Saturn. Okay, do you remember this? Yes. Its distance from the sun, and always remember the sun is the center of our solar system, is the center. Okay, so every other object orbits around it, don't forget. So its distance from the sun is 9.5 AU. Remember, AU means astronomical unit. Astronomical unit. Okay, then time for one complete revolution is 29 years. Jupiter was 11.9 years, but Saturn is 29 years before it completes one revolution. Do you understand? Do you understand? Okay. Okay. The next one, after Saturn, what do we have? We have Uranus. Uranus. Do you understand? Yes. As you can see, the values are increasing as we go down, right? The values are increasing. This shows what I was explaining, because they are far from our sun, from our solar system, which is the center of the solar system, the sun. They are far. So the farther they become, the larger the number. That is how it is. That's how you're seeing the numbers, right? From Jupiter, increase, increase, increase down here. So how many times, or the times for one complete revolution? This one, 84.01 years. Remember the other one was 29. This one is 84. See how it's increasing. 84.1 years. So you wait before it will complete one complete turn back to this place. 84.01 years before it will get back to complete this revolution. Okay? Do you understand? Fine. So moving on, the next one is after Uranus. What do we have? After Uranus, we have Neptune. Neptune, and its distance from the sun is 30.1 AU, and the time for one complete revolution is 164.8 years. It's very far, right? 164 rather 0.8 years. Then our last one is what? Pluto. Pluto. Okay? Pluto. And Pluto is distance from the sun is 39 AU. 39 AU is very far and is very small. That's why, if you remember our last class last week, I mentioned of dwarf, right? Yes, you can see it from here because its value is very large. It's a dwarf planet. 39 AU, and its distance, right? No, not distance. The time for one complete revolution is 247.7 years. Could you imagine? 247.7 years before it's complete one revolution. Do you understand? If you understand, fine. If you do not understand, please ask me questions. I will explain. Any question? Okay, so wrapping it up, today we're talking about the component of the solar system, their location, which is the distance from the sun, and we've itemized them already from Mercury down to Pluto, and their astronomical unit, which is the distance from the sun and the time it takes, all of them takes to complete one revolution. I think with this, even if not all, I guess you get something. And if you do not understand anything that we've taught here, please ask me question on the, the comment below. But before I leave you guys, can we please take home something? I want us to test our memory, our brain. In a tabular form, list the components of the solar system with their distance from the sun. I've given you all, right? So it's easy. Just go back to your note, go through it and work on this. I'll see you guys next our next class. Bye.